that?
Ew.
Only question, the whole practice exam they gave you?
In the practice exam I had, that was the only one. So. But if you think about it, there's 63 questions in the practice exam. There's 50 chapters in the book. 48. You're likely not to get more than one question per chapter. Okay. So what I want to do is this is the water potential. These are the water potential problems from the old lab book. And so I just photocopied it because the new lab book has a big section about water potential. So it's obviously important, and they'll definitely have something on this on the AP exam. But they didn't give problems and stuff in the new lab book. So I wanted you to show you this is where the reading is.
What page?
Over water potential. Page S50, it starts on S52. See understanding water potential? See that? And so I want to spend some time here looking at this and working over this handout that I gave you. And we'll do this together today. That's what we're going to do. So I'm going to give you about 5 minutes here. I want you to read starting on understanding water potential all the way through to S54 where it stops at learning objectives. Stop there. I'm going to do that right now. So we've all read it. And then I'll talk about it with you. Okay. All right. You are to be reading now. You can just let the film run. You need a workbook? Is that why you're doing that?
Yes.
don't have to read to S54. Just stop at the bottom of S53. Give me a thumbs up if you're done. All done? We're done? Okay, so what does this symbol mean? Do y'all know?
Psi.
What is that?
Greek letter.
Water potential.
It is a Greek letter.
Water potential.
Stands for water potential.
Y'all with me over there, ladies?
Yeah.
Psi is water potential. The total water potential is equal to
Pressure potential.
psi s, which is what?
Solute.
Solute potential. And now what is solute potential talking about?
Negative ICRT.
No, negative ICRT.
But what does that mean? That's the formula for it. So
Negative
what are we
ICRT.
talking about when we're talking about solute potential?
Ionization.
Yeah.
How would you say it to someone who didn't know anything about biology?
Like,
The stuff after the water.
The stuff that's what in the water?
It's dependent on the solute concentration.
Dissolving.
The stuff that's dissolved in the water. That's what this is talking about.
so what's the potential part of it?
Well, potential has to do with basically the higher the water potential, the more water that is there. Is kind of a good way to think about it. Okay.
So what is it?
So if you have a lot of solutes dissolved in the water, and there's less water there, right?
Hmm.
So this value will be lower. The more solutes in the water, the lower the water potential.
So it's always going to be 0 or negative.
Why does that make it lower? I don't get it.
Well, the solute potential will always be 0 or negative. That's correct. What's that?
Why does it make it lower?
Well, water potential is basically a term saying how much water is there. So if you put solutes in the water, there's less water in it, right?
How?
So this number will be lower because the solutes are there instead of water.
But the water didn't disappear.
The solutes are taking up space. If you pour salt in the water, you'll see the level rise.
So does the
Takes up
solute
that space.
absorb some of the water?
Yeah.
The solute takes the place of some of the water.
Does it absorb it? Or
Not
does
really.
it go?
So it's not like displacement.
It displaces it, you could say.
But then it doesn't move it. Like
But there's still the same amount of water.
Yeah.
It's added and not absorbed. And what happens to the water that's?
It just moves. It moves out of the way.
So then there's
So
still
where
the
did
same amount though.
Yeah.
Right?
Well, It's the same amount of water, but you've added solute to it.
So it's
more
less of just pure water.
It's less of pure water.
Okay.
Correct. Okay?
So pure water is 0.
Pure water has a solute potential of 0. Water with solute in it, the solute potential will be negative.
Wait, water
So
with
what-
what?
If the water has solute in it, the solute potential here will be negative.
So,
What is
Because water potential is saying how much water there is there.
Mhm.
If you put solute in it, there's less water overall. You're not saying that in a certain amount of space, if you add solute, this is solute in the water. Now in this amount of space, there's less water because there's solute there.
Okay. So how does adding solute make it have less solute potential?
Solute, the water potential, the higher the water potential, the higher the
The
psi
less
s, the
solute.
more water there is. The more percentage water there is. Okay?
The more water is the less solute.
The higher the solute, the more
Pressure.
water.
Yes.
How?
Now the higher the solute potential, the higher this value is, the more water there is.
Ugh.
Is that
It's just a number that they give to water
But what
potential.
is
So
it?
solute potential doesn't have anything to do with how much solute's in the water.
Yes, the greater the amount of solutes that are in the water, the lower this value will be.
what is it the potential to do?
Is
Okay.
that just like, is there a specific reason for that, or is that just?
It's used to figure out these mathematical
So the more
equations that we're
solute,
going
the more
to.
water?
No.
The more-
So that's just to help you figure out.
Pure water
What?
equals no solute.
Okay.
The psi s will equal
0.
0.
That
Okay.
makes sense because the
Added
formula is-
solute.
Add solute,
Okay.
So that all equals 0.
not pure water. Not pure water.
So pure water, not pure.
Equals more solute. This will be a negative value.
The water.
Wait, how is it negative?
Why is it negative?
Because it's
Since you're
negative.
adding.
So the more solute I add, the further down this is going to go. These values are used to see which way water moves. Water will always move from high solute potential to
So you're
low
saying there's something
solute
else in the
potential.
water too.
What's that?
There's something else in the water too then.
That's right. If there's something else in the water, this value is going to go down. Water
Absorbed into the
always moves from high water potential to low water potential.
So it goes from when there's not as much
I
solute.
couldn't hear both at the same time. Say that again?
It's going down because it's going into the object. Being
I'm not sure what you're saying.
like the potential's going down because the solute, the water's being absorbed into the object.
The water's being absorbed into the object.
Like if you put something in the, I don't know.
Well, the water potential of a beaker with just salt in it is a lower potential, right?
That's right.
So
And
it's-
water will always move into the areas with salt, because water moves from a high water potential, a high psi to a lower psi, a lower water potential. You were going to ask something.
Is it the higher water potentials when there's not as much?
Yes. If there's not much solute, if it's just pure water, it has a high water potential. If there's a lot of solute, if it's real salty, it has a low water potential. Water always moves from high water potential to low water potential. From where there's a lot of water to where there's not as much water, where it's salty.
Okay, so you're saying that solute potential. Yeah. I don't understand the solute potential part. I understand what solute does.
I don't
If you
understand
add
the
salt to
negative
water,
impact.
the water potential goes down.
That's according
I
to
get
the
that.
formula.
But I don't understand. You said that when you add solute to it, the solute potential goes down.
If you add solute to water, the solute potential will go down.
How? I don't understand.
It just does. When you add solute to water, the solute potential goes down.
Well,
What is
it goes-
solute?
And that means water will move toward the solute. Water will move toward.
Is solute a thing being added?
solute is like salt or sugar or anything that will dissolve.
Well, like
in
in
water.
the pictures, there's like a potato or something like that.
It's a potato cell.
Well,
A potato cell has a bunch of solute in it, a bunch of sugar dissolved in it.
So why is the solute going down?
It doesn't. A potato cell is not pure water, so it's got solute dissolved in it. So the solute, so the psi s of a potato cell will be a negative number, maybe like -3, where the psi s of pure water is 0. So this is pure water,
So the water.
and this is the potato cell.
So the water's going to go into the potato cell.
So if you have a potato cell in pure water, water will go from 0 into the potato cell.
So the water's going into like salt or something?
Water will go toward wherever there's solute, wherever there's salt, wherever there's sugar, water will go that way.
Okay, so if you have like a beaker full of like regular like water and it's like 0, and then you put like a bunch of salt in there, then the solute thing will go down.
This number will go down. It'll become a negative number.
Because the water is going into that.
Here's my pitcher right here.
Okay.
It has 0 water potential. It's pure water. I pour salt in there or sugar. When it dissolves, all of a sudden it's not 0 anymore. It's -3. The water's there, the sugar's there, but now this has a -3 water potential because we added solute.
And is the solute potential low now too?
Yes, the solute potential is the measurement of how much water overall, the purity of water in the beaker.
So it's either 0.
And when we put salt
So
in there, the purity went down, so it's negative.
It's negative just because it's like getting less pure.
well,
So what
look
would
at
That's
the,
right.
well,
what
look at
So
the
like
formula.
0 is like the ultimate like purity.
It's negative.
0 is the ultimate purity.
So only pressure can be
Oh,
positive.
so we can
Only pressure can be positive.
So
Yes,
what is, so solute potential's never positive?
that's right.
Okay.
It can only be 0.
What if
So
it was
never goes
positive?
up.
It can't ever go up
Just look
higher
at
than
the, look at the
0.
formula. It's
You can't get
negative-
more pure.
negative I
Could it-
CRT, and if you have an I of 0, the whole thing's 0.
That's
So
correct.
multiply by 0, it's
What's the
0.
word one?
So that's why.
There's
it's
no-
zero.
EKF, did you have a
There's
question?
no I.
Yeah,
I is 0.
so
I
it's
mean, there's
either,
no solute in there.
it's
so
either
it's
0,
not
completely 0, pure water, and then when you put stuff in it, then it's negative.
That's correct.
So it's never like above 0.
Nope, not solute potential.
Or water.
But the total water potential,
It's never negative.
psi, is equal to the solute potential, which is either 0 or negative, plus the pressure potential. The pressure potential can be positive. It's how much pressure the water is under. If you push really hard on the water from all directions,
It's a
the
compressor.
pressure goes up and can get real high. Question,
Can
EKF.
the solute potential be more negative than the positivity of the pressure potential?
Yes.
So it can be a negative.
Can pressure
Yes.
potential be negative?
So the whole pressure can be negative. Water-
Pressure could be negative.
Water,
if
water
it's
potential
suctioning
can
outward.
be negative.
So will the water
Yes,
potential?
or positive.
Will the
Yes.
water potential ever be like above 0?
Could be.
What does that mean?
That means it's the higher the water potential. Water, it's always, in all these problems you're going to do a comparison. Water will always go from high water potential to low water potential. So if you compare the values of the two, let's say one solution right here, the one they make sugar in, has a water potential of -3.
So the higher it is, the more likely it is to move to a lower potential.
The higher it is, the more likely it is to move somewhere.
Okay.
Mm-hmm.
Okay.
Yeah. So if we take this, here's a sugary solution that has a water potential of -3. Were y'all asking about that? And we drop in a cell that has a water potential of -1.
So they come negative.
What's water going to do?
Into the cell.
They're both gonna be negative.
It's
too.
gonna
It
go
goes from
towards
high to
negative
low.
3. because
Water
it
moves
goes
from high to low. Water's going to move out. Right?
So it's gonna be negative.
If we drop in a cell that has a -4 water potential,
It's gonna go into the negative.
it's going to go in.
So it'll be -3, -3.
And it'll go in, and what happens when water starts going in here, it builds up pressure. The solute might not change, but the pressure will change. And it'll drive the pressure in there. The solute potential might be -4, but when water comes in, it starts building up pressure on the walls, so the pressure potential could go to +1, and when you add the two together, they're going to equal out. There's going to be an equilibrium eventually.
Or equal the same thing. And then
So that inside equals -3 and outside equals
And
negative.
then when it stops,
And then it'll stop. Okay? So let's turn to let's answer these questions together, page 14. Page 14 on the handout I gave you. It should look like this. Look up here at this picture. It should look like this.
Figure 1.5.
Number 1. If a potato core is allowed to dehydrate by sitting in the open air, what would the water potential of the potato would the water potential of the potato cells decrease or increase?
Decrease.
And why?
Decrease.
Increase.
Increase.
Question number?
Decrease.
Isn't there water in the air?
Increase
The
because
line.
the water is higher in the potato than it is in the
No.
air.
14.
Increase because you're losing water.
It would increase because you're losing water.
The water potential of the potato cells would decrease, become more negative,
Yeah.
because the concentration of solutes within the cells increases as the potato cells dehydrate.
You said it one
So
more
we're
time.
gonna decrease because.
Slower this time.
The water potential of the potato cells would decrease, become more negative, because the concentration of solutes within the cells increases as the potato cells dehydrate.
So
Because the concentration.
I got it.
the concentration of the cells within.
Listen to what I'm saying and see if you can understand it. The water potential of the potato cells would decrease because the concentration of solutes, that's dissolved substances, within the cells increases as the potato cells dehydrate. The water is moving, you see? The water is leaving and going into the air.
And
So the amount of sugars total, the concentration of sugars goes up as you lose water.
more concentrated.
There's
More
more.
concentrated, more
There's more
sugars
solute.
compared to water.
There's more solute.
So the word potential is throwing me off here. So
Don't worry about the word potential. It just means the amount of water. The amount of water.
I would think that.
If something has a high water potential,
And
it's got a lot of water in it.
Okay. See,
That's the way I like to think about
I'm
it.
gonna say it has a high water potential.
It's got a lot of percentage water in it. It's got the purity of the water is up. Or it's got a lot of pressure. And that'll cause that water to want to leave and go somewhere else.
But if there's no pressure, even if it is really,
If there's no pressure, the pressure potential is 0. And you're only worried about what the solute
yes.
You would think the water potential would be the potential of water moving into it.
Yeah, but it's not.
So the only thing that changes in the potato is drying out is C, the molar concentration, right?
That's correct.
I see. So now ours is the pressure constant, so just, what does that mean?
Normally, under atmospheric pressure, it's 0. Everything's going to be 0. Unless you start adding pressure somehow, like the turgor pressure that builds up as the water rushes into the plant.
So that's turgor pressure basically?
That's turgor pressure.
I see, I thought right.
Okay, number 2.
Me and Emery got it. Yeah, we got it.
Listen, if a plant cell, stop talking. If a plant cell has a lower water potential than its surrounding environment, and if pressure is equal to 0, is the cell hypertonic or hypotonic to its environment? Will the cell gain water or lose water? And explain your response.
Hypo because it's gaining water.
It's hyper
Can I
because it
say-
needs to take
can I
in
say-
more.
EKF, what do you have your hand up? What are you going to say?
I said the cell gains water and the cell is hypotonic because it's moving from the higher concentration to the lower concentration.
Do y'all agree or disagree?
I think it's hypertonic.
It's
It has a
hyper-
lower-
Okay.
it's hypertonic.
Savannah, what do you think? You have your head down. What? Is the plant cell hypertonic or hypotonic?
Wait.
I thought it was hypo.
It's
Needs
hyper.
more.
'Cause it's
Hyper.
Needs more.
I always remember the word hyper means you got a lot of sugar in you.
Yeah. Okay, so
You
it's
got a lot of
hyper.
solute in you.
Ooh.
Here's the answer. The plant cell is hypertonic to its environment and will therefore take up water. The higher the solute concentration, the more hypertonic the cell is. And the lower the solute potential and water potential.
Can you repeat that?
The higher the solute concentration, the more hypertonic the cell is to its environment. And the lower the solute potential, and the lower the total water potential. When the pressure potentials of the cell and the environment are both zero, the movement of water depends entirely on solute concentration.
So the higher the solute concentration, the lower
The water potential. That's right. Does that make sense?
So is hypotonic when the water leaves the cell?
Well, if a cell is hypotonic to its environment, then water will leave the cell.
So it's
If
a relative thing.
If
So
a
high.
cell, it's a relative thing. EKF, if a cell is placed in a hypotonic solution, then water will come into the cell. These are relative terms. Hypotonic and hypertonic are relative terms.
So if a cell's placed into a hypotonic, it will take in water.
It will. Hypotonic means there's not much sugar, it's mostly water. So if the cell is in a hypotonic solution, water will rush into the cell. If the cell is hypotonic to the solution, water will rush out of the cell.
The cell is hypertonic and needs water.
If the cell's hypertonic, it's got a lot of sugars in it,
It needs water.
and water will rush into it.
So is that when we like get in the ocean and like dries up?
No, that's because of lipid. That's because of the drying out of loss of lipids from the skin. That's a different thing. Look at number 3.
Is it full?
In figure 1.5, the beaker is open to the atmosphere. That means the pressure is 0. We're not worried about pressure when they say open to the atmosphere. So what is the pressure potential? I just answered the question.
0.
I thought they were going to ask something different. I gave away that answer. Okay, I can just sit here and do this by myself. The atmosphere, we consider atmospheric pressure 0. So if it builds up pressure greater than what the atmosphere is pushing down, then your pressure is going to be positive.
Like underwater?
Higher. Like if you have a cell in this beaker and water is rushing in it, pressure builds up. It's called turgor pressure. And then that pressure starts going up greater than 0. But if it's just talking about open to the atmosphere, it's always going to be 0 in that case. In figure 1.5, where's the greatest water potential? Is it in the beaker or is it in the dialysis bag? You got to look at the picture.
The dialysis.
Write it down and let's see. Write down what you think it is, and I'll tell you the answer. 0.4% sucrose in the solution outside. 0.1% sucrose in the dialysis bag. What has the greatest water potential? How many say bag? How many say beaker?
I think I can explain why.
It's the bag.
Really?
And the reason why is because the dialysis bag has less sugar, less solute.
Less solute means more water.
The less solute, the more solute you add, the lower this number gets. It gets more negative.
Get more water.
I got it.
So there's more water in the dialysis bag.
No, I got it.
So there's the greatest water potential in the dialysis bag. There's more purity of water in the dialysis bag. It has a higher water potential.
Oh.
Do you see what I'm saying?
I see. If it said greatest solute potential, it would be beaker, right?
No. Because the more negative you get, the lower you are. That's less.
I see.
The higher you get, the more closer to zero you get, the greater it is.
I see. So what does the beaker have that the dialysis bag doesn't?
The beaker has 0.4% sucrose. The dialysis bag only has 1.1% sucrose. So there's more sugar in the beaker. There's more sugar, this number goes down. You want to pick the higher of the numbers.
I see.
So the dialysis bag is going to have the higher of the numbers because it's less negative.
I see.
Okay?
Get to work backwards.
What about 4?
What?
What about 5? Water will diffuse blank.
Out of.
Into the bag or out of the bag?
Out.
Out. No, yes, out.
Because the water purity is
How many
higher.
think out of?
What backwards?
Okay, I feel like the answer is out of.
How many think into?
I feel like it has to be, I mean, I know like the answer's probably out of, but if it's 0.4 and 0.1 on the inside, doesn't it go from high to low? So why wouldn't it go into it?
It goes from high water potential, which is in the bag.
I mean, that's what's confusing.
There's
She's
more water.
she's thinking and you're saying high solute potential.
No,
it
high
goes from
water.
solute potential and stuff.
There's
Goes
more
from
water.
high
Well, since the pressure's here, it's all dependent on solute potential.
But she thinks that's what that where water moves
There's
from.
a
High
higher-
solute potential.
There's a higher
Instead
concentration
of high water.
pure water.
Water goes from high water potential to low water potential. So where there's more solute, that's where the water will go. Which has more solute?
Out of.
The beaker.
The beaker has more solute, right?
So,
It goes
Water always
towards.
goes where there's more solute.
It goes towards more solute.
Unless there's a lot
towards
of
less
pressure there.
water.
So you're out of that.
So it'll go out of the bag.
I don't like this.
water always goes where the
What?
Outside of it.
Yeah.
So it's going to make it.
Hey, tell me this. I got a potted plant. I pour a bunch of salt water by the roots. What's going to happen to the plant?
It's gonna die.
Water will come out of the plant toward the solute, toward the salt.
So water always goes to the salt. To more solute.
Unless
Yeah.
there's a lot of pressure somehow.
The beaker has less.
If somehow if I water my plant with salt water and then put a huge amount of pressure at the roots, then the water couldn't get out of the plant because of all the pressure. So you can overcome a very low solute potential, let's say this was negative 20, with a very high pressure. Let's say the pressure was positive 21. Then we got a positive total value, and that's higher than even pure water. Pure water will not rush into salt water that's under really high pressure.
Then can you
The
explain-
pressure keeps the water from going in there.
Then what's the low to high thing that was on like the 3 questions before that? Like number 2.
Number 2, the plant cell has lower water potential. So here's a plant cell. Let's say it has low water potential. Let's say the water potential is negative 20. That's
Oh,
pretty
it's
low.
water potential. Okay, I get it. Got it.
Okay?
Okay, question.
That's why you.
Yes.
What about stuff that's like miscible in water, like alcohol? Does that work or no?
We won't worry about that. They won't have questions about that on
So.
Why doesn't alcohol freeze? It's just a random question.
That's,
I don't know. It just doesn't.
it does freeze, right?
Yeah.
You gotta get the
Cold
temperature
enough.
cold enough. It freezes
Well,
at a
in
lower point.
normal
Has-
freezers.
Has to do with something about the hydrogen bonds in water and stuff.
Mm.
Okay, so this graph right here, what they've done is they've taken zucchini and they've put it in various sucrose solutions. They put it in distilled water in 0.2 molar, 0.4 molar, 0.6 molar, and here's the change in the mass of the zucchini cores. And what they want you to do here is they want you to graph this. And so at the bottom, you can go ahead and write this. At the bottom, I would put, see sucrose molarity? I would put 0 right there. That's the distilled water. And 0.2, and 0.4, 0.6, 0.8, and 1.0. Are you making this on your graph? Oh, look at you.
You only use a tiny bit of that.
And then on the side, I would put the change. Now, percent, there's a 0 in the middle, and so I might go minus 10, minus 20, minus 30, minus 40. And on this side, plus 10, plus 20, plus 30, plus 40.
Wait, what? Can you say the side again? Sorry.
Minus 10, minus 20, minus 30, minus 40.
Duh.
Plus 10, plus 20, plus 30, plus 40. And then I'm going to make a graph. Y'all remember, we did an experiment kind of like this.
Yeah, we did.
Y'all remember it?
Potato things.
And I would do a line of best fit after you plot those points and see where this line crosses the graph. That will be the mass of your zucchini cores. And that's what this letter B questions. What is the molar concentration of solutes within the zucchini cells? And you're supposed to answer that. And then this will be your homework, and this isn't due until Tuesday, is to answer these questions related to this graph on the zucchini cores. And this is the stuff you're likely to get on the AP test. Now, that'll be a grade. I'll grade that as a homework. Now remember, you got your test over all those chapters that are on the syllabus.